This unit we're going to start talking about transformations, and the first one that we're going to talk about is a translation. So a transformation is changing the size, location, or orientation of a figure. We can slide it, we can flip it, we can rotate it, and we can dilate it or change the size of it. An isometry is a figure that has the same lengths, angles, and area after you have transformed it. There are three different ones that are isometric. Three of our transformations are isometric, and one is non-isometric. We'll talk about those throughout this unit. The pre-image, these are just some vocabulary words you're going to see in the problems to make sure that you understand. The pre-image is the original image before or pre-transformation. And then the image is the new figure after the transformation. So if it says what's the image, it's asking after you moved it. Now, specifically today, we're going to talk about translations, and today you'll be able to write the coordinates of a translated figure based on what we talk about today in the translation rules. So a translation is a slide. You take your pen and you slide it over. You slide it to the right or left or up or down, or you slide it over and up, and it has a result that is basically is a diagonal, a vector movement. So it's a combination of those moves. The notation, you can write it in several different ways. A translation can be written like this, where it will say, so like say for instance, it says that a T, capital T for translation, and it looks like that. That means that it is going to go X plus 1 and Y plus 2. So your rules can be written like this, or it can be written like this, where XY becomes or yields X plus or minus a number, and then Y plus or minus a number, depending on how it moves. So the original coordinates of A, B, and C in this image are as shown. If I want to translate the triangle up 4 units, up and to the right are positive directions, down and to the left are negative directions. So if I want to move it up 4 directions, then that means that only my Y values are going to change. Up and to the, these are your Y directions, these are your X directions, up and down are your Y axis, and right to left are your X axis. So your new A, notice the notation here, A prime, that means the new A. So, or the image of A, and the image of A then would be up 4 units. So I would take -2 and 5, but I'm going to move that up 4 units, so it will be -2 and 9. B will be 3, or X value doesn't change if I'm only moving up, and then I'm going to move up 4, so -3 plus 4 is 1, and then C is going to stay at -4 in the X, and then it's going to move up 4, so -1 plus 4 is +3. So those are the new locations for triangle ABC after it has been translated up 4 units. The rule is X stays the same, so X stayed X. I didn't change my X value, but I took my Y value and I added 4 to every Y value. That's how the rules work. If I want to translate to the left 6 units, go back to our original. This is A prime. We want to go back to our original figure. So I'm going to move to the left 6. So basically what's going to happen is I want to go to the left. That's a negative direction, so it's going to be -6. So we're going to do that. Right and left is our X direction. So we're going to take our X value and subtract 6. So we're going to take our -2 and 5. We're going to move it to the left 6. So -2, and it's going to go to the left 6. -2 minus 6 is -8. And then it's going to stay on the same level in the Y axis. Okay, B was at 3. We're going to move to the left 6, so it's 3 minus 6. That puts me at -3, and then the -3 Y value still stays the same. And then C, it was -4. I'm going to subtract 6. -4 minus 6 is -10, and then -1 because it didn't change in the Y direction. I just simply moved right or left. So this one is an up and down movement. This one is a right and left movement. The translation is that X and Y becomes my X went back 6. It went to the left 6. My Y value stayed the same. It did not change at all. Now, what if you do both directions? What if you change right and left, up and down in the x direction and the y direction? So let's look and see what happens here. So these were my original values on this figure is the same as the one that we did on the front. So my A prime, or my image, is going to go to the right 4 and down 5. So to the right 4 and down 5. So this right is my x direction, y is my down direction. So every value, my x values are going to go up by 4, and my y values are going to go down by 5. So -2 plus 4 is 2, and 5 minus 5 is 0, and you would continue in that way for all of them. 3 plus 4 is 7. -3 minus 5 is -8. That's where you have to be really careful. -3 minus 5, because we're minus 5. And then -4 plus 4 is 0, and -1 minus 5 is -6. So here's what it was going to look like. So if you took this original right, we're going to move it to the right 4. So you're taking this point right here and you're going 1, 2, 3, 4, and then you're going down 5. 1, 2, 3, 4, 5. I ran out of room, but that'd be 7 and -8. So your new B, or your B prime, goes right there. You move A, 1, 2, 3, 4. 1, 2, 3, 4, 5. So you can also do this graphically. 1, 2, 3, 4. 1, 2, 3, 4, 5. And if you check, look, see, we can see all of our numbers: 0, -6, 7, -8, and 2 zeros. So we did everything right. So you can do it on the graph, or you can do it by knowing how the rule works. So my translation rule was my x and y became x plus 4 and y minus 5. That's what your translation rule looks like. So now let's look, because you can do a combination. So what if I wanted to move it to the right 4 and down 5, and then I wanted to take this figure and I want to move it again? So now I moved it to here. This is my A prime, B prime, C prime. Now I want to move it again. It says to translate A prime, B prime, C prime. Up 6, up is y, right? Up 6, and left 8. So that's x minus 8. Notice these are not written, right? Don't always assume that the first one is x, y, or the first one is right, left, and the second one is up, down, okay? Always pay attention to which axis goes with which one, so keep these straight. In fact, if we want to write the rule here, it's going to be x minus 8, because when we write our ordered pairs, x always comes first, and then y plus 6. Now notice this right here, it's double prime. That means you're changing your change. So I'm moving this triangle now, not the original. Okay, so now we're going to take these numbers and we're going to change them again. So I'm going to take my new x values and I'm going to subtract 8. So 2 minus 8 is -6, and 0 plus 6 is 6, and then you continue on. 7 minus 8 is -1, and -8 plus 6 is -2. And then C is 0 minus 8 is -8, and -6 plus 6 is 0. And so that is where our figure ends up after we go to the right 4, down 5, and then up 6, and back 8, to the left 8. Now, we could have done that all in one motion. It says, what single rule could translate ABC to A double prime, B prime, C prime in 3 and 4? So I went to the right 4, right? I went to the right 4, and then I went back 8. So my overall rule could have been +4 minus 8 is -4. Oh, I don't need that there. And then my y value, I went y minus 5, and then I did +6. So I went -5, and then I went up 6. Well, the result is -5 plus 6 is +1. So the one rule that I could have done where I would have ended up in the same place is, let me show you with A. A double prime was at -6, 6. It would have ended up right here. That's where A double prime is. Okay, so what I could have done is I could have started right here at A, and I could have gone back 1, 2, 3, 4, and up 1. So I didn't have to go from here to here, and then from here back. I could have just gone back 4 and up 1 and shortcutted the whole process. Okay. In the figure shown, so say we take this same figure right here, in the figure shown, what is the rule that would translate ABC if C is at 2, negative 4? So starting over again, C prime is at 2, negative 4. 1, 2, 3, 4. So here is our new C prime, and I want to know what's the rule that gets me there. Well, count where you're going in the x direction. So your x direction, I went from C to C prime, so I'm going to go to the right. 1, 2, 3, 4, 5, 6. So I went to the right 6, so that's plus 6, and then I went down 1, 2, 3. So it would be y minus 3. So that would be the rule that would take this figure and shift it down so that C will map onto C prime. Okay, now another kind of question. What is the image translation of RFC, triangle RFC, with coordinates at R and F and C is given, that undergoes a translation, capital T, if you ever see this notation, of 4, negative 1? That means this rule right here, x plus 4, because it's a positive 4, and y minus 1, because it's a negative 1. So this is the rule that I want to go through. Okay, so what happens then is just the same. R prime, it was at 0, negative 6, so now it's 0 plus 4, which is 4, and negative 6 minus 1, which is negative 7. That's where your new R is. F prime, your new F, will be at negative 9 plus 4, which is negative 5, and 0 minus 1, which is negative 1. And then C, we want our new C, our image of C, is at negative 12 plus 4, which is negative 8, and negative 5 minus 1, which is negative 6. Okay, so all of those are finding the coordinates using the translation rules. And it'll be given in different ways. Okay. Then the last one is we want to work backwards. The translation of triangle APQ is at A prime, P prime, and Q prime. This is my image, right? My image is after the movement. So I have moved it to there. If the coordinate of A was originally at 7, negative 10, what are the coordinates of P and Q, the original P and Q? So let's see what it took to go from A to A prime. These are the two that we have that match, and so we need to use these. So to go from A to A prime, I went from 7 to 11. So my X value increased by 4. My Y value was negative 10, and then it went down 1 more to negative 11. So it's going to be, I don't need that middle piece, I keep doing that, minus 1. So you take your Y value and you subtract 1. Now this is the rule that you're going to use, that's the rule that took you to get from A to A prime. Well, if I have P, I need to back up, right? So basically what you want to do is you want to do the opposite. Is what did I add 4 to get negative 7? What did I subtract 1 from to get positive 6? So your original point P, if you take negative 7 and you subtract 4, because we're going backwards from P prime, this is what it took to get there, right? And now I'm saying, okay, I want to go forward to that. So negative 7 plus 4 would be negative 3. So my original, my pre-image of P was at negative 3, and then 6, add 1 to it, it was at negative 3, 7. Because if I take negative 3 and I add 4, oh, no. Minus, I'm sorry, that'll be negative 11. I'm sorry, I don't want to cause any confusion. I'm sorry. It's negative 7, and we're going to go back 4 more. Right? Because we added 4, so we have to do the opposite. So negative 7 plus negative 4 is negative 11. I apologize about that. That's negative 11 and then 7. So it's a good thing I double checked, because now negative 11 plus 4 is negative 7, and 7 minus 1 is 6. And so it gave me back my original image that I had. And then Q, we want to know where did it start. So again, We ended at -9, so let's go backwards 4. So 9 minus 4 would be 5, and then -13, and we need to add 1. So -13 plus 1 is -12. Let's do a quick double check, make sure it works. So 5 plus 4 is 9, and -12 minus 1 is -13. So these are the pre-image points that would give me this image, and you have to work backwards. So this is the rule that A went through to get to A prime. You have to use it backwards to get your original points. So a translation is a slide. It is a movement up, down, right, left, and you are either adding or subtracting depending on whether you're going up or to the right or down and to the left.